So we'll read the question next problem. In an engine governor of Porter type, the upper and the lower arms are 200 mm and 250 mm respectively. See here, so the length is different here. So Q will come into this problem. Okay, because the lengths are different, definitely the angle will be different. Which angle? Look at the diagram. So this is 200, this is 250. Even though they are directly hinged on the axis. Okay, so since the length is different, definitely this angle will be different. Here, so alpha and beta are different, which means if alpha and beta is different, you have to find Q and substitute Q in the formula. So this problem is a little bit complicated, right? It's not difficult, but you have to use another formula, not the formula what you used earlier. Q will come. Okay. In an engine governor of Porter type, the upper and the lower arms are 200 mm and 250 mm respectively and pivoted on the axis of rotation. The mass of the central load is 15 kg. Mass of each ball is 2 kg. Friction of the sleeve together with the resistance of operating gear is equal to 24 Newton at the sleeve. Limiting inclination of the upper arms to the vertical is 30 and 40. So what does this tell you? At the lower RPM, upper arm angle is alpha. Okay. Always remember beta is down, alpha is up in any governor. In all the governors, what you are going to see after this also, alpha is in the upper arm, beta is in the lower arm. No change in that. So what is the question tell you? Limiting inclinations of the upper arm to the vertical. So 30 degree and 40 degree. So what does this tell you? When the radius will be lesser, at that time your angle will be lesser. So that is your lower RPM alpha value. When your speed increases, ball tends to move out, therefore your alpha value will increase. Maximum value of alpha is 40 degree. These two are given indirectly. Okay. Find taking friction into account the range of speed of the governor. Clear? So write on the given data. Length of the links. So BP. B is the center of the ball. So B to P is 200. B to D is 250. So central mass is 15 kilogram. Ball mass is 2 kilogram. Frictional force is 24 Newton. Okay. So here I will like to point out one thing. In Kurmi textbook, in the question they have mentioned as 25 Newton. Okay, but inside the problem everywhere they have used 24 Newton. So there is a mistake in the textbook. So you can correct it. Okay. So alpha 1 is 30 degree, alpha 2 is 40 degree. Okay. First of all, let us find out the minimum and maximum speed of the governor, N1, N2. Okay, then only you can find the range of speed. Minimum and maximum position of the governor is shown in figure below. The same figure that is given in the question. Okay. So let N1 equal to maximum speed, N2 equal to minimum speed. Sorry, I've told it in the wrong way. So N1 is the, let's take the first diagram speed as N1, second diagram speed as N2. Just by looking at the diagram, I can tell the radius is lower, height is higher for the first figure, which means it is at a lower RPM. Okay, if I am rotating at a very high speed, my ball will be moving out. Naturally, my radius will be large. So just by looking at these two figures, you can tell this value is larger for the second figure than this one. So that naturally tells me this is the lower speed, correct? So therefore N1 is the minimum speed, N2 is the maximum speed. So first diagram is N1, second diagram is N2. Okay, that's how I am deciding minimum and maximum. If same way the figure is given in reverse order, if at all this was your first figure and this was your second figure in order, then N1 will be maximum speed, N2 will be minimum speed. You have to decide that by looking at the radius. Just by looking you can tell. Okay, same way. Here height is larger and height is smaller in here. You just project this line, you can see the height is larger here. You put a straight line. Okay. Only when the speed is lower, the height will be larger. They are inversely proportional. So I can decide that this is the lower speed. Okay, this is higher speed. That's how I am writing here. N1 minimum speed, N2 maximum speed. Okay. So from figure A, we find that minimum radius of rotation R1 equal to. So now I know one side of the triangle is 200, one angle is also known. Minimum speed case alpha is 30 degree. Therefore I am using sin theta, right? So what I am doing in this right angle triangle, so come here, in this right angle triangle, right, what is the value of sin 30? Sin 30 equal to opposite side. Alpha is here, therefore this is your opposite side. Alpha equal to R1 is the opposite side, radius of rotation. This is your radius of rotation, right? Look here. R1 by hypotenuse is 200. So therefore R1 equal to 200 sin 30. That's why I have written this. So 0.2 into sin 30, 0.1 meter. Clear? That's why I am finding my R1. So height of the governor, now you know two sides. So one is 0.2, one is 0.1. Using Pythagoras theorem, find the third side. Okay. So square root of, or is going for cos theta. You can do it both way. You will get the same answer. Okay. Either you can go for putting a square root and write 200 square. Since you have found out this side as 0.1, this is 0.2. You can write this as 200 square minus 100 square. Or 200 sin, say this is sin 30. So this will be cos 30. That also you can do. So BP cos 30, 0.2 into 0.866, it comes around 0.1732. These calculations you have to do and verify whether you are getting the same answer. Just don't have a look and say okay, right? From figure A, what is DG? DG. This lower portion height. So this is not H. This is not height of the governor, but I am finding it out. Okay. So why we are doing it, we will see. So find this out using, you know, the two sides. This also you know. This also you know. So find it out using Pythagoras theorem. The third side. It comes around 0.23 meter. So from that I am going to find out the angle beta. That's why I am finding out that side. I want to know the value of beta, right? So then only you can go for calculating Q. You know the value of alpha, it is given in question, but you don't know beta. What is the formula for Q? Tan beta by tan alpha. So you should know beta value. You don't know it. So I am finding out the one side and then tan beta formula I am substituting and I am finding out the value of tan beta. You don't have to find beta. Tan inverse also you don't have to do, just find tan beta. Because you exactly don't need beta, you need tan beta to calculate Q. Okay. So therefore tan beta. So I know all three sides. Now this also I found out as 0.23 meter, 0.25 meter. This is 0.1 because this is the radius of rotation. All three sides are known. Now come to this triangle and write tan beta. Opposite side by adjacent side. So opposite side is 0.1, adjacent side is 0.23. So substitute that 0.1 by 0.23, it comes around 0.4348. So if you need, you can do the tan inverse. If specifically they ask what is the value of beta, you can calculate beta. Otherwise, just leave it. Tan beta equal to 4348. So Q equal tan alpha. Alpha value is known 30 degrees. So find tan alpha. Tan 30, 0.5774. Okay. So Q equal to tan beta by tan alpha. All these things are for the first RPM. Therefore, put the suffix 1. Q1 equal to tan beta 1 by tan alpha 1. So 0.4348 by 0.5774 is 0.753. Clear? Any doubts up to this? Okay. So Q1 is 0.753. Now we will go into the formula for we know that when the sleeve moves downwards, frictional force acts upwards and the minimum speed is given by. So this is your formula. Okay. So mg. Now lower RPM case, I already told you, put minus here because sleeve move down. Friction acts in the opposite upward direction, so it is opposite to the weight direction, therefore I am putting minus. Okay, here H1, all other things will remain same for calculation. Okay, so this is your most complicated formula for speed. So small m into g plus capital M into g minus f divided by 2. When q comes into picture, this divided by 2 and 1 plus q will come. If q is not there, this q will also become 1. So 1 plus 1 2, you can cancel these two things. That's how the formula got simplified. But now q is there in the picture, therefore this divided by 2 and 1 plus q will come. Correct? You remember that? Okay, so 895 by h1. So all the values you take, capital M is 15 kg, small m is 2 kg, frictional force is 24 Newton, q is 0.753, h1 is 0.23. So all these values you remember, substitute everything. So this is 2 kg, 2 into g, capital M is 15 kg, 9 into g divided by 2. So this is 24 Newton friction is here. Okay. So similarly q is 0.753, therefore I am putting 1 plus 0.753, 1.753, 1 plus q multiplied by 895 divided by h1. So I think I have written this wrongly. h1 was 0.1732. 0.23 is the beta side, adjacent side of beta, right? Do you remember? When we found out beta, this value came around 0.23. This is not height of the governor is the other side, upper side. This height. It is 0.1753. I'm sorry, 0.1732. Okay. So in the previous slide it was there. I have taken this wrongly. This is 0.1732. If you go to the previous, I will show you. If you go to some previous slides, you will see H1. So see here. Already we have calculated H1 to be 0.1732. I've taken the value wrongly. Okay. So this is a change. Clear? So now I think you understood where and all I put what numbers I put where. So now that comes around 33,596. This calculation you have to do very very carefully. If you get if you are not in regular usage of calculators, you will not get this answer. Somewhere you will make mistake with the brackets. Okay. So 33,596. Take a square root of that. So you will get 183.3 rpm considering friction. Okay. Here no friction condition is not asked in the question. You are directly doing only friction. Okay. So 183.3. Therefore N1 is 183.3. Similarly, we are going to do the second case. Second figure you take. So alpha is known directly. So using alpha, I am going to write sin theta for this triangle. So sin 40. Sin 40 equal to R2 by hypotenuse 200. So 200 sin 40 is your R2. So 200, that is 0.2 into sin 40. 0.1268 is R2. Okay. So that's how I find out the radius. Similarly, cos theta, if you put, you will get the height of the governor. So height of the governor, R cos 40, it comes around 0.153. So from figure B, I am finding out the beta 2 value now. This length I am finding out, then I am going to find out this is 250 and this is the radius of the governor, which you have found out as 0.1268. So it's 0.25. So 0.25, 0.1268, if you substitute in this Pythagoras theorem formula, you will get the third side. Using that, you can go for tan beta. Okay. So 0.25 square minus 0.1268 square, it comes around 0.2154, height of the governor. I mean, this is not H2. Don't write this as H2. This is DG. Always the height is in the upper link to the radius only. This is not H. Okay. So tan beta is BG by DG. So look at the lower triangle. Same way for this triangle. This I know. This I know. So opposite side by adjacent side. So this is 0.1268. This is mine 2154. 0.1268. Opposite side by adjacent side. It comes around 0.59. Tan beta value is given. So alpha value is 40 degree. You can directly write tan alpha. Tan 40 0.839. Clear? So now using tan beta and tan alpha value, find Q. 0.59 by 0.839. 0.703 is the Q2 value. Clear? So now let us go for calculating the N2. Here N2 is the higher speed, therefore flea will move upwards, friction downwards, which coincides with the weight direction. Put F as plus, and this Q2 value and H2 value. These three things will vary, right? So M is 15 kg, 2 kg, frictional force 24 Newton, Q2 is 0.703, H2 is, I think this is wrong, 0.1268 or something. Go back and see. Some mistakes are arising when I am doing the PPT. What is H2? Correct only, 0.1532. Correct, 0.1532. So put all the values. So 2 kg here in place of small m, 2 kg, capital M 15 kg into 9.81. Frictional force is 24 Newton plus 24. So divided by 2, Q2 is 0.703. 1 plus 0.703, I am directly writing as 1.703. So 2 into 9.81, 895 divided by 0.1332. Solve it, you will get 49,236. Take square root, you will get N2 is 222 rpm. Clear? So now speed range. So 222 minus 183.2, 38.7 rpm. So that is the required answer, right? Since range of speed is 38 miles. It is taken from your Gumi textbook, problem 18.4.